Hi, I'm Ishan from Fun FTC, and we're here with Team 12376, Yolk, from Park City, Utah. We got Nathan and Ryan right here. They're going to talk to us about their really simple but really effective robot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting Fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. Hey FTC fans, are you ready for Freight Frenzy? Join us after kickoff live all weekend, September 18th and 19th, as we'll be out at Kettering University for the Bulldogs Robot in 30 Hours at youtube.com/first updates now. You'll get detailed breakdowns of game elements, the field, and prototyping and testing of robot components and assemblies. Watch live, view short videos after, and ask questions for the Kettering team at youtube.com/first updates now.
Starting us off, can you talk to us a little bit about your intake? You got some noodles, you got some gecko wheels with compliant wheels. Talk to us a little bit more about that.
Okay, so we try to make it like our intake as simple as possible. So these are actually like surgical tubing. So these are grippy and like they're flexible. And they bring them up to these. These are actually gecko wheels. And then these little pieces are parts of compliant wheels. So that gives it like grip and like pulls it up and just goes straight into this wheel. And this wheel is kind of like where the rings are stored. This ring, so it lifts them around. And like rings are stored like 1, 2, and 3.
Do you want to show us a little bit about how those rings travel up?
Turn it on.
Jam. And so then it just holds it in place. And then what happens when you're ready to shoot? You have like this big wheel in the middle. You don't have to turn on your shooter.
Yeah, so basically this gate will lift up, and then we can run the intake and this in-between wheel, and all 3 rings will just shoot however fast we want it to, depending on the motor of this wheel in between.
And what sort of iterations did you go through in this entire design?
We went through a lot of iterations, just testing different materials mostly. See, this inside yellow wheel is actually made out of a flexible filament that he happened to have, and we just wrapped it in yellow tape to make it look nice. But we went through a lot of other iterations, like we initially actually had cardboard just taped on here, just to try to test different materials, and it worked well, but we wanted to try different things. And for example, these 2 intake things, we also used 2 different materials. We tried more cut-up compliant wheels for the intake, or surgical tubing on the second stage of the intake, but yeah.
And so you got a lot of white parts on your robot. Can you talk about like how you 3D printed them, what you 3D printed them on, what materials you're using, stuff like that?
So yeah, the white parts are printed with white PLA. And so these big pieces, they're 2 different prints that we created in CAD. And I'm pretty sure they each took about like 8 hours each. And then, so that's most of and also all the inside wheel is 3D printed. And then there's one last 3D printed part here. This is for the wobble goal.
Awesome. Do you want to show us a little bit about your wobble goal?
Yeah, so it's pretty simple. It pretty much just goes down, and then it can close and open, and then when we want to take it up, we just bring it up, and then we can just drop it over the wall by just opening that again, and it will just fall out pretty naturally.
Awesome. And you got 2 cameras on the bot, right? Most teams got 1 for the starter set. What are you using the second one for?
Yeah, so this webcam you can see is on right now. It actually detects the backboard of the red and blue goals. And so what that does is allows us to localize the robot and know the position of it at all times, even if our robot does slip. So for example, odometry, it actually doesn't slip like odometry because it will always be able to correct itself because it just uses the webcam to see where the backboards are.
Awesome. So is that OpenCV that you're using? Awesome. Really cool robot here. Really simple. It shows you what you can do with a really simple frame, similar to the Gobble the Strafer kit. You said you did a little bit of tweaking, but really simple frame shows that you can build a really successful robot even with limited amount of parts. Thanks for watching, and we'll see you next time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow, and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.